Hey guys, good morning. Welcome to the Aerodynamics class. Today we are going to see the aircraft or airplane pull down maneuvering condition. In last two classes we have seen the level turn of the airplane or aircraft and pull up maneuvering of the aircraft. Now the third case, the pull down case. In pull down case we are going to find out what is the pull down radius, what is the pull down rate. There are two things we will see. But here also we can take the aircraft in the level flight. Suddenly it getting pulling down. Let us take a level flight, that is a lift is equal to weight. Whereas in pull down case, that is a let us take the aircraft case, pull down case. This is an inverted aircraft. So here the lift as well as weight will get in downwards direction. Both forces will act in a downward direction. It will start pulling down. So the pull down radius, the point you are there. Now we are going to find what is the pull down radius r as well as what is the pull down rate theta or omega for pull down case. Now the same equation for this case, mass of the aircraft and this is the velocity. This is the velocity of the aircraft and mass velocity square divided by the turn radius r is equal to the force will be L plus W. That is lift plus weight. Here also we are going to find what is the turn radius. Yes, r is equal to m v infinity square divided by L plus W. The mass will be weight times gravity, v infinity square L plus W. Here we can use the rearranging equation W by G V infinity square L by W plus 1. Here L by W is equal to load factor. Now we can replace here turn radius. Now this equation will change as R equal to W here. We can cancel the W by W. So we will get V infinity square divided by G. Replacing load factor N by W as N plus 1. So this R will be turn radius of the airplane or aircraft during pull down maneuvering. Right? Now we are going to find out what is the pull down rate. This is a level flight. Now we can find out the pull down rate. So what is the pull down rate? That is omega. Omega will be V infinity by R. So already we have got the R value, turn radius. So we can substitute here. V infinity by R will be V infinity square. I will erase this. So V infinity divided by G load factor plus 1. So you can cancel this V by V square. So we are getting G gravity into load factor plus 1 whole divided by V infinity square. That is the turn radius. This is the turn rate. Turn rate omega of the aircraft during pull down condition. Pull down condition. It means for any turn radius or the turn rate, it is purely depends upon the gravity, velocity of the aircraft and the load factor. Load factor is lift divided by weight. The lift of the aircraft and the weight of the aircraft. This involves the turn radius as well as the turn rate is equal to V infinity square by G N plus 1. So turn radius and turn rate is derived for the aircraft pull down maneuvering condition. So last 3 classes including this we have seen about level turn of the aircraft and airplane, pull down maneuvering, pull down maneuvering. For all 3 cases we have evaluated what is the radius of the condition, what is the rate of turn. Right? We will see in SNS. Thank you.